Tonight, we're going to do something that might break your brain a little bit. We're going to compare the size of the universe to everything you know. And I'm not talking about vague statements like it's really big or space goes on forever. I'm talking about actual comparisons that will make you physically uncomfortable. Because here's what most people don't grasp. When we say the universe is big, we're not just talking about something larger than Earth or larger than our solar system. We're talking about something so monumentally, so incomprehensibly vast that the distance from Earth to the most distant thing you can imagine. Let's say the edge of our galaxy is essentially zero compared to the full scale of the cosmos. By the end of this journey, you're going to understand exactly what that means. And I promise you, you'll never look at the night sky the same way again. Asterisk before we dive in. If you find these deep explorations of cosmic scale interesting, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a huge difference for me. Now, let's begin this journey through scale. Asterisk your world. Right now, asterisk, let's start with something completely familiar. The room you're in right now. Look around. Maybe you're in a bedroom, maybe a living room, maybe you're outside. The walls around you, if you're inside, are probably somewhere between 10 and 30 feet away. That's a distance you understand perfectly. You've walked across rooms like this thousands of times. You can estimate these distances by eye without even thinking about it. Asterisk, your brain is exceptionally good at handling distances like this. Evolution made sure of that. Your ancestors needed to accurately judge the distance to a tree they wanted to climb, to a river they needed to cross, to an animal they were hunting. Distances of a few feet to a few hundred feet, these are scales your brain handles effortlessly. Asterisk, now think about your neighborhood, the distance to your local store. Maybe half a mile or a kilometer away, the school, the park, the places you go regularly. Your brain still handles these distances well. You know roughly how long it takes to walk there, how long to drive. These distances are part of your daily mental map. Asterisk, your city or town extends this further. Maybe it's 10 miles across, maybe 50. You probably don't know every street, but you understand the general layout. Downtown is that direction. The suburbs spread out this way. The highway cuts through over there. You can navigate. You have a sense of the space. Asterisk, at this scale, distances are still comprehensible, still human. You can travel across your city in an hour or two. You've done it many times. The distance is large, but it's not abstract. It's real and knowable. Asterisk, let me give you some actual numbers. To anchor this, the room you're in is probably about 15 feet across. That's roughly for 0.5 meters. Your neighborhood might extend about a mile in each direction. That's 1.6 kilometers. Your city might be 20 miles across, about 32 kilometers. Asterisk, these are the scales of human life, the scales evolution prepared you for. The scales you understand intuitively. Asterisk, now we're going to start breaking that intuition. Asterisk, the first leap. Your country. Asterisk, let's zoom out. Think about your country. If you're in the United States, you're looking at a nation roughly 3,000 miles from coast to coast, about 4,800 kilometers. A road trip from New York to Los Angeles takes about 40 hours of driving, typically spread over 4 or 5 days. Asterisk, this is where distances start to feel different. You can't see across your country. You can't walk across it in any reasonable time. A cross-country drive is an event, something you plan for, something that takes days and requires preparation. Asterisk, but it's still achievable. People make this journey all the time. You could start driving today and be on the other coast in less than a week. The distance is vast by the standards of your daily life, but it's not abstract. Millions of people have crossed it. You could cross it if you wanted to. Asterisk, here's something to consider. If you drove at highway speeds, 70 miles per hour, non-stop, without sleeping or eating or stopping for gas, which obviously you can't do, but imagine it would take you about 43 hours to drive coast to coast. Less than 2 days of continuous driving. Asterisk, that's a comprehensible amount of time. Long, yes. Tedious, certainly, but you can imagine sitting in a car for 43 hours. You can wrap your mind around it. Asterisk, now let's go bigger. Earth. The first real challenge. Asterisk, the Earth has a circumference of about 25,000 miles at the equator. That's roughly 40,000 kilometers. If you wanted to drive around the entire planet and you could somehow drive on water at 70 miles per hour, it would take you about 357 hours. That's nearly 15 days of non-stop driving. Asterisk, nobody drives for 15 days straight. But 15 days is still a comprehensible time frame. It's 2 weeks. You've experienced 2-week periods many times in your life. You know what 2 weeks feels like. Asterisk. So Earth, as large as it is still within the realm of human comprehension. We've explored all of it. We've mapped every continent, charted every ocean. We have photographs of every region. We know Earth intimately. Asterisk. The surface area of Earth is about 197 million square miles. That's 510 million square kilometers. Big number, but let me give you context. If you wanted to visit every square mile and spent just 1 second in each location, it would take you over 6 years of continuous travel. Asterisk. 6 years is a long time, but it's not incomprehensible. You've lived through multiple 6-year periods. You know what 6 years feels like. So even Earth's entire surface area, while vast, is still theoretically explorable by a single determined person given enough time. Asterisk. But here's where things start to shift, because Earth, as large as it seems when you're standing on it, is almost unimaginably tiny compared to what's out there. Asterisk. The moon, 240,000 miles of nothing. Asterisk. The moon orbits Earth at an average distance of about 238,855 miles. Let's round that to 240,000 miles, or about 384,000 kilometers. Asterisk. That's roughly the distance you'd travel if you drove around Earth's equator about 9.5 times. Asterisk. Now, driving around Earth once would take you about 15 days of non-stop driving. Multiply that by 9.5, and you're looking at about 140 days, nearly 5 months of continuous driving at highway speeds to cover the distance to the moon. Asterisk. But of course, you can't drive to the moon. There's no road. There's no air. There's just empty space. Asterisk. When the Apollo astronauts traveled to the moon between 1969 and 1972, they used the most powerful rockets ever built. The Saturn V rocket accelerated them to speeds of about 25,000 miles per hour. That's roughly 40,000 kilometers per hour, about 350 times faster than highway driving. Asterisk. And even at that incredible speed, faster than any human beings had ever traveled before, it still took them about 3 days to reach the moon. Asterisk. 3 days to cover a distance that would take 5 months of driving. That gives you a sense of how fast 25,000 miles per hour really is. And yet, it's barely fast enough to make lunar travel practical. Asterisk. Here's something that might surprise you. If you could somehow place every planet in our solar system in a line between Earth and the moon, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, they would all fit in that 240,000 mile gap with room to spare. Asterisk. The distance to the moon is about 30 times Earth's diameter. Imagine placing 30 Earths in a row, one after another. That's the empty space between us and our nearest celestial neighbor. Asterisk. And the moon is close. Cosmically speaking, it's right next door. We can see it clearly with our naked eyes. We've sent humans there. It's about as close as anything in space gets. Asterisk. But compared to what comes next, the moon might as well be touching us. Asterisk. The sun, 93 million miles away. Asterisk. Our sun sits approximately 93 million miles from Earth. That's 150 million kilometers. We call this distance 1 astronomical unit, or O. It's the yardstick we use to measure distances within our solar system. Asterisk. Let me help you understand what 93 million miles mean. Asterisk. If you drove at highway speed 70 miles per hour toward the sun, it would take you about 151 years to get there. You need to start driving when you were born, continue driving every moment of your entire life, and you still wouldn't make it. Your children would need to continue driving their entire lives. Your grandchildren would need to drive most of their lives. 3 generations of continuous driving just to reach the sun. Asterisk. The Apollo spacecraft that went to the moon traveled at about 25,000 miles per hour. At that speed, it would take about 155 days, over 5 months, to reach the sun. And remember, 25,000 miles per hour is incredibly fast. It's about 7 miles per second. In 1 second, you travel the length of about 35 football fields. Asterisk. The fastest spacecraft humans have ever built is the Parker Solar Probe. It reaches speeds of about 430,000 miles per hour when it's close to the sun, using the sun's own gravity to accelerate. That's about 120 miles per second. And even at this absolutely blistering speed, the fastest any human-made object has ever traveled, it still takes months for the probe to complete its orbits near the sun. Asterisk. Light travels at 186,000 miles per second. That's the fastest speed possible in the universe. Nothing can go faster. and even light takes about 8 minutes and 20 seconds to travel from the sun to Earth. Asterisk, think about that. When you look at the sun through proper filters, please don't look directly at it. You're not seeing it as it is right now. You're seeing it as it was 8 minutes and 20 seconds ago. If the sun suddenly exploded at this very moment, we wouldn't know for over 8 minutes. We keep seeing it shine, keep feeling its warmth, completely unaware that it had already ceased to exist. Asterisk, the sun contains about 86% of all the mass in our solar system. Everything else, all the planets, all the moons, all the asteroids and comets combined makes up less than 0.15%. The sun is so massive that you could fit about 1.3 million Earths inside it. Asterisk, and yet, the sun is just one star among hundreds of billions in our galaxy. There's nothing particularly special about it. It's an average, middle-aged star. Not too big, not too small, not too hot, not too cold. Utterly ordinary by cosmic standards. Asterisk, but we're still just getting started. Asterisk, the solar system. Billions of miles. Asterisk, let's talk about the planets in our solar system and the distances involved. Asterisk, Mercury, the closest planet to the sun, orbits at about 36 million miles, roughly 58 million kilometers. That's still about 150 times the distance from Earth to the moon. Asterisk, Venus comes within about 25 million miles of Earth at its closest approach, about 40 million kilometers. That's still over 100 times the distance to the moon. Asterisk, Mars, at its closest, is about 34 million miles away, about 55 million kilometers. When it's on the opposite side of the sun from us, it's about 250 million miles away, roughly 400 million kilometers. Asterisk, when NASA operates rovers on Mars, there's always a communication delay. At Mars' closest approach, radio signals traveling at the speed of light take about 3 minutes to travel from Earth to Mars. Commands sent to a rover take 3 minutes to arrive, and any response takes another 3 minutes to come back. That's a 6-minute round trip for communication. Asterisk, at Mars' farthest distance, the delay stretches to over 20 minutes each way, more than 40 minutes for a round-trip communication. This means you can't drive a Mars rover in real time like a remote-controlled car. You have to plan every movement carefully, send commands, and wait. If something goes wrong, you might not know about it for over 40 minutes. Asterisk, then we reach the gas giants. Asterisk, Jupiter, the largest planet in our solar system, orbits at an average distance of about 484 million miles from the sun, roughly 778 million kilometers. When Jupiter and Earth are on the same side of the sun, the distance between them shrinks to about 365 million miles, roughly 588 million kilometers. When we're on opposite sides, it stretches to over 600 million miles, nearly a billion kilometers. Asterisk, Jupiter is massive. Over 1,300 Earths could fit inside it. It contains more mass than all the other planets combined. And yet, Jupiter is tiny compared to the sun. About 1,000 Jupiters could fit inside the sun's volume. Asterisk, Saturn orbits at about 890 million miles from the sun, approximately 1.4 billion kilometers. That's nearly twice Jupiter's distance. When the Cassini spacecraft orbited Saturn from 2004 to 2017, there was over an hour communication delay each way. Scientists would send commands and wait over 2 hours to see the results. Asterisk, Uranus sits at roughly 1.8 billion miles from the sun, about 2.9 billion kilometers. Neptune, the farthest planet, averages about 2.8 billion miles, approximately 4.5 billion kilometers. Asterisk, at Neptune's distance, sunlight takes over 4 hours to arrive. The sun, which appears as an overwhelming presence from Earth, would appear as just a very bright star from Neptune. Still the brightest object in the sky by far, but just a point of light, not a disk. Asterisk, the Voyager spacecraft, which flew past Neptune in 1989, is the only human-made object to have visited it. When Voyager to reach Neptune, there was over 4 hours of communication delay each way. Every command sequence had to be programmed days or weeks in advance, uploaded to the spacecraft, and executed autonomously. If something went wrong, by the time engineers on Earth knew about it, the situation could have changed completely. Asterisk, beyond Neptune lies the Kuiper Belt, a vast ring of icy bodies including dwarf planets like Pluto. Pluto orbits at an average distance of about 3.7 billion miles, roughly 5.9 billion kilometers from the sun, when NASA's New Horizons spacecraft flew past Pluto in July 2015. It was so far away that light took over 4.5 hours to make the journey. The spacecraft had been traveling for 9.5 years to reach Pluto. 9.5 years of continuous motion through space at speeds of around 36,000 miles per hour, asterisk, and Pluto is still considered part of our solar system's inner regions. The edge, where our sun's influence fades asterisk far beyond the Kuiper belt, lies the Oort cloud, a spherical shell of icy objects that marks the true outer boundary of our solar system. The Oort cloud begins at about 2000 from the sun. That's 2,000 times the distance from Earth to the sun and extends outward to perhaps 100,000 astronomical units, asterisk. Let me put that in perspective. The inner edge of the Oort cloud is at about 186 billion miles, roughly 300 billion kilometers. That's 2,000 times the distance from Earth to the sun, asterisk. If you could drive there at highway speeds, it would take you about 300 to 1,000 years. Modern humans, Homo sapiens, have only existed for about 300,000 years. You could have started driving at the dawn of our species, and you'd be just arriving at the inner Oort cloud today. Asterisk. Light from the sun takes about 2 weeks to reach the inner Oort cloud. The outer edge, at 100,000 astronomical units, is about 9.3 trillion miles away, roughly 15 trillion kilometers. Light takes nearly 2 years to travel that distance. Asterisk. Think about that. The sun's gravitational influence extends for nearly 2 light years, and in all that vast space, there's almost nothing. A few icy bodies, widely scattered, loosely held by the sun's gravity. The Oort cloud is more concept than place, a vast spherical volume, where comets occasionally originate when disturbed by passing stars or galactic tides. Asterisk. Voyager 1, launched in 1977, is currently the most distant human-made object. It's been traveling for over 47 years at about 38.0 miles per hour, roughly 61,000 kilometers per hour. It's now about 15 billion miles from Earth, roughly 24 billion kilometers. Asterisk. That sounds like a lot. And it is, by any human standard. Voyager 1 has traveled farther than anything we've ever built. It's passed beyond the heliosphere, the bubble of charged particles that the sun creates around itself. Voyager 1 is officially in interstellar space. Asterisk. But here's the thing. Voyager 1 has completed only about 0.05% of the journey to the outer Oort cloud. After nearly 50 years of travel, it's covered less than 1/4% of the distance to our solar system's edge. Asterisk. At its current speed, Voyager 1 won't reach the inner edge of the Oort cloud for another 300 years. It won't exit the outer Oort cloud for about 30,000 years. Asterisk. Let that sink in. The fastest human-made object, traveling for 30,000 years, just to exit our solar system's gravitational boundary. Asterisk. And the Oort cloud is still considered our cosmic backyard. Asterisk. The first star, 25 trillion miles of emptiness. Asterisk. The nearest star to our sun is Proxima Centauri, part of the Alpha Centauri system. It's about 4.24 light years away. Asterisk. A light year is the distance light travels in 1 year. Light moves at 186,000 miles per second. In 1 year, that works out to about 5.88 trillion miles, roughly 9.46 trillion kilometers. Asterisk. Proxima Centauri is about 25 trillion miles away, roughly 40 trillion kilometers. That's 4.24 light years. Asterisk. Let me help you understand this distance. Asterisk. Remember, the sun is 93 million miles away. Proxima Centauri is about 268,000 times farther than that. If the distance from Earth to the sun was 1 inch, Proxima Centauri would be about 4.2 miles away. Asterisk. At highway driving speed 70 miles per hour, it would take you about 40.6 million years to reach Proxima Centauri. Modern humans have existed for only about 300,000 years. You need to drive continuously for 135 times the entire span of human existence to cover that distance. Asterisk. The Apollo spacecraft that went to the moon traveled at about 25,000 miles per hour. At that speed, reaching Proxima Centauri would take about 114,000 years. You could have started the journey at the end of the last ice age, when humans were just beginning to develop agriculture, and you'd still be traveling today, still tens of thousands of years away from arrival. Asterisk. Voyager 1, traveling at 38,000 miles per hour, would take about 75,000 years to reach Proxima Centauri, and it's not even headed in that direction. Asterisk. Even light, the fastest thing in the universe, needs 4.24 years to make the journey. When you look at Proxima Centauri through a telescope, it's too faint to see with the naked eye. You're seeing light that left that star 4.24 years ago. You're seeing Proxima Centauri as it was over for years in the past. Asterisk, if Proxima Centauri exploded right now, we wouldn't know about it for over 4 years. The star could already be gone, and we'd keep seeing it shine normally until 2029 or later. Asterisk, the space between stars is almost incomprehensibly empty. If you could shrink the sun down to the size of a grain of sand, about 1 millimeter across Proxima Centauri would be another grain of sand, located about 4.5 miles away. The tiny specks separated by miles of absolutely nothing. Asterisk, this is what interstellar space is like. Vast, empty, cold. The average density of matter in interstellar space is about 1 atom per cubic centimeter. For comparison, Earth's atmosphere at sea level contains about 2.5 times Ki atoms per cubic centimeter. Interstellar space is emptier than the best vacuum we can create in laboratories on Earth. Asterisk, and Proxima Centauri is the nearest star. Most stars are much, much farther away. Asterisk, Sirius, the brightest star in our night sky, is about 8.6 light years away, roughly 50 trillion miles or 81 trillion kilometers. The light you see from Sirius tonight left that star in 2016 or so. You're seeing Sirius as it was 8.6 years ago. Asterisk, Betelgeuse, the red supergiant in the constellation Orion, is about 550 light years away, roughly 3,000 to 100 trillion miles or 5,000 to 100 trillion kilometers. The light you see from Betelgeuse tonight started its journey around the year 1475. During the Renaissance, before Columbus sailed to the Americas. Asterisk, at this scale, even light takes centuries to travel between stars, and light is the fastest thing there is. Asterisk, our galaxy, 100,000 light years across. Asterisk, all the stars you can see with your naked eye. Every single one belongs to our galaxy, the Milky Way. On a dark night, far from city lights, you can see the Milky Way is a pale band of light stretching across the sky. That band is the combined glow of billions of stars, so numerous and so distant they blur together into a luminous haze. Asterisk, the Milky Way is a spiral galaxy roughly 100,000 light years across. That's about 588 quadrillion miles, roughly 946 quadrillion kilometers. Asterisk, let me write that out. 588 quadrillion miles. Asterisk, at highway speeds. Driving from one side of the Milky Way to the other would take about 956 billion years. The universe itself is only about 13.8 billion years old. You need to drive continuously for about 69 times the current age of the universe to cross our galaxy. Asterisk, even light takes 100,000 years to cross the Milky Way, light that left one edge of our galaxy when modern humans were first leaving. Africa is only just now reaching the opposite edge. Asterisk, our sun sits about 26,000 light years from the galactic center. We're in the Orion arm, a minor spiral arm between the larger arms. When you look toward the constellation Sagittarius, you're looking toward the heart of our galaxy, toward a region so dense with stars and gas and dust that it glows with the combined light of billions of suns. Asterisk, at the very center of the Milky Way lurks something extraordinary. A supermassive black hole called Sagittarius A*. Asterisk. It contains the mass of about 4 million suns, all compressed into a region smaller than Mercury's orbit. Asterisk, the Milky Way contains somewhere between 100 billion and 400 billion stars. The uncertainty is enormous because we're inside the galaxy, trying to count stars through obscuring dust, unable to see many regions clearly. But the best estimates suggest around 100 to 300 billion stars. Asterisk, if you could count one star per second without ever stopping, it would take you over 8,000 years to count all the stars in our galaxy. And that's just one galaxy among trillions in the observable universe. Asterisk, our sun orbits the galactic center at about 500,000 miles per hour, roughly 800,000 kilometers per hour. That sounds incredibly fast, and it is, by human standards. At that speed, you could travel from New York to Los Angeles in about 18 seconds. Asterisk, but the Milky Way is so vast that even at this tremendous velocity, it takes our sun about 230 million years to complete one orbit. The last time the sun was at its current position in the galaxy, dinosaurs were just beginning to evolve on Earth. They rose to dominance, ruled the planet for over 160 million years. When extinct 66 million years ago, mammals took over, and humans eventually emerged, all in the time it takes the sun to go around the galaxy once. Asterisk, Earth is about 20 galactic years old when it orbits around the center. In all that time, in all those journeys around the galaxy, the Milky Way itself is just one galaxy among trillions. Asterisk, at galactic scales, Earth doesn't just shrink, it essentially ceases to exist. The Milky Way is 100,000 light-years across. Earth is about 8,000 miles across. The ratio between these sizes is approximately 1 to 73 quintillion. That's 1 to 73,000,000,000,000,000,000,000,000 asterisk. If you scaled the Milky Way down to the size of the continental United States, about 3,000 miles across, Earth would be about 3 trillionths of an inch across. Far smaller than an atom, far smaller than a proton, below the scale of subatomic particles, essentially nothing. The local group, millions of light-years asterisk, the Milky Way isn't alone. It has neighbors. Together with about 80 other galaxies, we form the local group, a gravitationally bound collection spanning roughly 10 million light-years asterisk. The largest member of the local group is the Andromeda Galaxy, also called M31. Andromeda is about 2.5 million light-years away, roughly 14.7 sextillion miles, or 23.6 sextillion kilometers, asterisk. Let me write that out. 14,700,000,000,000,000,000,000,000 miles. Asterisk. Andromeda is bigger than the Milky Way. It contains about 1 trillion stars, roughly twice what our galaxy has. It's about 220,000 light-years across, more than twice the Milky Way's diameter. Asterisk. The light you see from Andromeda tonight started its journey about 2.5 million years ago. At that time, on Earth, early human ancestors like Homo habilis were just beginning to use stone tools. Modern humans wouldn't evolve for another 2.2 million years. All of human evolution, from those early tool users to today, happened while light from Andromeda was traveling toward us. Asterisk. Andromeda is actually moving toward us at about 250,000 miles per hour, roughly 400,000 kilometers per hour. In about 4.5 billion years, it will collide with the Milky Way. The two galaxies will merge over hundreds of millions of years, their stars swirling together, eventually forming a single giant elliptical galaxy that astronomers have already nicknamed Melkometa. Asterisk. Between the Milky Way and Andromeda lies about 2.5 million light-years of space. In that vast gulf, there are a few small dwarf galaxies, but mostly there's just emptiness. The average density of matter drops to perhaps 1 atom per few cubic meters, even emptier than interstellar space within galaxies. Asterisk. The local group spans about 10 million light-years. At this scale, galaxies are like islands separated by vast oceans of nearly empty space. The Milky Way is one island, Andromeda is another, and dozens of smaller islands, dwarf galaxies, dot the space between. Asterisk. The Virgo supercluster, 110 million light-years asterisk. The local group is part of something even larger. The Virgo supercluster. This enormous structure contains at least 100 galaxy groups and clusters, spanning about 110 million light-years asterisk. At the heart of the Virgo supercluster sits the Virgo cluster, located about 54 million light-years from us. This cluster contains about 1,500 galaxies. Some are enormous, far larger than the Milky Way, asterisk. M87, a giant elliptical galaxy at the heart of the Virgo cluster, contains about 1 trillion stars. It's roughly 120,000 light-years across. M87 is also famous for hosting a supermassive black hole with a mass about 6.5 billion times that of our Sun. In 2019, the Event Horizon Telescope captured the first image of a black hole shadow, and it was M87's black hole they photographed. Asterisk. The Virgo supercluster is so large that light takes 110 million years to cross it. When light left the far side of our supercluster and began heading our way, dinosaurs ruled Earth. They would continue ruling for another 44 million years before the asteroid impact that wiped them out. Mammals would rise to dominance, primates would evolve, and eventually, after tens of millions of years, modern humans would appear, all while that light was traveling through the supercluster. Asterisk. If you made a scale model where the Milky Way was the size of a quarter, about 24 millimeters across, the Virgo supercluster would be about 35 meters wide. That's the size of a large house. Everything you've heard about up to this point, the sun, the solar system, the distances between stars, the entire Milky Way would fit on a coin in this model. Asterisk. In Earth would be far smaller than an atom in that model, smaller than a proton, beyond any scale you could measure or see. Asterisk. Laniakea, 520 million light-years asterisk. In 2014, astronomers discovered something even larger. They found that the Virgo supercluster is just a small part of an even more massive structure called Laniakea, which means immeasurable heaven in Hawaiian. Asterisk Laniakea contains about 100,000 galaxies spread across 520 million light years. All these galaxies, including our Milky Way, are slowly flowing toward a common center of mass. Asterisk the Milky Way is located near the outer edge of Laniakea, where being pulled, along with everything else in this vast structure, toward a region called the Great Attractor. This is an area of enhanced gravitational pull hidden behind the disk of our own galaxy. We can't see the Great Attractor directly because the Milky Way's dust and stars block our view in that direction, but we can detect its gravitational influence on galaxy motions throughout our region of space. Asterisk light takes 520 million years to cross Laniakea. When light left the far side of this structure and began heading toward us, the most advanced life on Earth were primitive sea creatures. Fish were just beginning to develop jaws. Plants hadn't yet colonized land. There were no trees, no insects, no dinosaurs, no mammals, just simple marine life. The entire history of complex life on land, from the first amphibians to today, happened while that light was traveling through Laniakea. Asterisk at this scale, even the Milky Way becomes essentially invisible. Laniakea contains 100,000 galaxies. The Milky Way is just one among 100,000. One data point in a vast cosmic structure. Asterisk and Laniakea is still not the largest structure we've found. Asterisk the cosmic web, billions of light years. Asterisk when you map the distribution of galaxies across the universe, a pattern emerges. Galaxies aren't scattered randomly, they organize into a vast cosmic web. Asterisk imagine a sponge, not a solid mass, but a structure with thin walls surrounding mostly empty bubbles. That's what the universe looks like at the largest scales. Galaxies cluster along filaments and walls, thin structures stretching hundreds of millions of light years through space. Between these filaments lie voids, vast empty regions where almost no galaxies exist. Asterisk some of these filaments are absolutely enormous. The Sloan Great Wall, discovered in 2003, stretches about 1.37 billion light years. That's 1,370 million light years. It contains tens of thousands of galaxies arranged in a relatively thin sheet. Asterisk the Hercules Corona Borealis Great Wall, discovered in 2013, might be even larger, roughly 10 billion light years across. That's about 73% of the radius of the observable universe. Light takes 10 billion years to cross this structure. When that light began its journey, our sun and Earth didn't exist yet. The solar system wouldn't form for another 5 billion years. Asterisk between the filaments are voids. The largest known void is the KBC void, about 2 billion light years across. Inside this void, there are very few galaxies, far fewer than in surrounding regions. The density of matter is much lower than average. Asterisk if you were somehow in the center of the KBC void and looked out, the nearest significant galaxy clusters would be about 1 billion light years away. The universe would seem much emptier from that vantage point. Asterisk these voids make up about 80% of the universe's volume. Most of space is essentially empty. The galaxies, galaxy clusters, and filaments occupy only about 20% of the total volume. The universe is like a vast ocean with occasional islands of matter scattered throughout. Asterisk at this scale, billions of light years. Earth's insignificance transcends normal language. The difference in size between Earth and the cosmic web is so vast that no comparison captures it. Earth is smaller than a single atom compared to these structures. Actually, that's not accurate. Earth is smaller than a quark compared to the cosmic web. The ratio is beyond comprehension. The observable universe, 93 billion light years. Asterisk the observable universe is the region of space from which light has had time to reach us since the Big Bang. It's not the entire universe, which might be infinite, but just the part we can theoretically observe. Asterisk the universe is about 13.8 billion years old. You might think this means we can see 13.8 billion light years in every direction, but the universe has been expanding the whole time. Space itself has been stretching. A galaxy that emitted light 13 billion years ago has moved much farther away during the time its light was traveling toward us. Asterisk the result, the observable universe is about 93 billion light years in diameter. That's the maximum distance from which light has had time to reach us, accounting for the expansion of space. Asterisk the observable universe is roughly 546 octillion miles across. Let me write that out. 5 for 6, miles asterisk. That number is so large it's essentially meaningless. Your brain can't process it. Nobody's brain can process it. We can write it down, we can calculate with it, but we can't truly comprehend what it represents. Asterisk within this observable universe, astronomers estimate there are about 1 trillion galaxies. Each galaxy contains anywhere from millions to trillions of stars. The total number of stars in the observable universe is estimated at around 100 billion trillion. That's a 2 followed by 23 zeros, asterisk for comparison. If every star in the observable universe was represented by a grain of sand, you need several hundred Earth-sized planets entirely filled with sand, packed solid, to represent them all, asterisk, and we now know, from observations by space telescopes like Kepler and TESS, that most stars have planets. The average is probably at least 1 planet per star, maybe more. That means there are likely 200 billion trillion planets in the observable universe. Maybe more. Asterisk, let that number sit with you for a moment. 200 billion trillion worlds, each one a place, each one with its own characteristics, rocky or gaseous, hot or cold, orbiting close to its star or far away. Some might have moons, some might have rings, some might have atmospheres, and some we don't know how many might have life. Asterisk, but here's what really should make your brain hurt. The observable universe is just what we can see. The actual universe is almost certainly much, much larger. How much larger? We don't know. It might be a few times bigger. It might be thousands of times bigger. It might be infinite. Asterisk, if the universe is infinite, then the observable universe with its 93 billion light-year diameter and 1 trillion galaxies and 200 billion trillion stars is precisely 0% of the total. An infinite universe would contain an infinite number of galaxies, an infinite number of stars, an infinite number of planets. Everything we can observe, everything I've described in this entire journey, would be essentially nothing compared to the totality of what exists. Asterisk, scale models. Breaking your intuition, asterisk, let me try to give you some scale comparisons. That might help though, honestly. At this point, all comparisons break down. Asterisk, if the observable universe were the size of Earth, about 8,000 miles across, the Milky Way would be about 1.3 inches in diameter, roughly the size of a walnut. Our entire galaxy, with its hundreds of billions of stars, compressed to walnut size in this model. Asterisk, at this scale, the local group would be about 16 inches across. The Virgo supercluster would be about 14 feet across. Laniakea would be about 66 feet across, roughly the length of a bowling lane. Asterisk, in Earth, in a model where the observable universe is the size of our planet, Earth would be about 510 to 22 meters across. That's 0.00015 meters. Far smaller than an atom, smaller than a proton, smaller than a quark. Below the Planck length, the smallest meaningful distance in physics. Asterisk, here's another way to think about it. If you could shrink the sun down to the size of a white blood cell about 10 micrometers across, then the Milky Way would be about the size of the continental United States. Andromeda would be roughly the distance from New York to Chicago, and the observable universe would be roughly the size of Earth's orbit around the sun, about 186 million miles across. Asterisk, in this model, where the sun is the size of a cell, Earth would be about 100 times smaller than an atom, completely invisible, beyond any microscope's ability to detect. Asterisk, or try this. If the Milky Way were the size of a coin, say, 24 millimeters across, then Earth would be about 1.7 times 10 to 13 millimeters across. That's 0.00017 millimeters. About 1/millionth the size of an atom. Asterisk, no matter how you scale it, Earth vanishes. Not just becomes small, vanishes. Becomes so tiny that it ceases to exist at any meaningful scale when compared to the cosmic structures around it. Asterisk, what this means, asterisk, so what does all this mean? Why does it matter that the universe is unimaginably vast and Earth is unimaginably tiny? Asterisk, for one thing, it provides perspective. Every human conflict, every war, every argument, every moment of anger or hatred, all of it happens on a planet so small that it essentially doesn't exist when measured against the cosmos. That doesn't make our lives meaningless. Your experiences matter to you, and they should. Pain is pain. Joy is joy. Love is love. These things are real and important, asterisk. But when you step back and remember where you are on a tiny rocky planet, orbiting an ordinary star in the suburbs of an ordinary galaxy among trillions of galaxies. It changes how you see things. The borders we draw seem arbitrary. The differences we emphasize seem small. The things we fight over seem petty. We're all on this planet together. All of us made of the same atoms, looking up at the same stars, trying to understand our place in this vast cosmos. We share far more than divides us. There's also something humbling about understanding cosmic scale. We like to think we're important, that we're the center of things, that what we do matters on some grand scale. And perhaps it does, in ways we don't understand. But cosmically speaking, we're incredibly, almost impossibly insignificant. The universe doesn't notice us. It doesn't care about our hopes and fears, our triumphs and tragedies. We're a brief flicker of consciousness on a tiny world in a vast cosmos. From the universe's perspective, we barely register. And yet this is the beautiful part. Here we are. On this tiny planet, matter has organized itself into forms that can think, can wonder, can look up at the night sky and ask questions about what they're seeing. We're capable of understanding the cosmos, at least partially. We can build telescopes, gather data, develop theories, test them, and gradually piece together the nature of reality. We're the universe's way of knowing itself. Through us, through our observations and our science, matter has become aware of matter. The cosmos has produced beings capable of understanding the cosmos. That's remarkable. That's extraordinary. Earth might be tiny, but it's special. As far as we know, it's the only place in the universe where life exists. We might discover microbial life elsewhere, perhaps on Mars, or in the oceans of Europa, or in Enceladus. There might be countless other worlds with life scattered throughout the galaxies. But right now, Earth is the only confirmed example. That makes Earth precious. Size isn't everything. What matters is what's here. And what's here is remarkable. A biosphere, an interconnected web of life spanning millions of species. Consciousness capable of understanding its own existence. Art, music, love, compassion, curiosity, wonder, all the things that make existence meaningful. The universe is vast. Earth is tiny, but Earth is home. And in a universe that's mostly cold, empty space, a small warm planet teeming with life is incredibly rare and valuable. The speed limit. There's another implication of cosmic scale that's worth understanding. It makes the universe essentially unexplorable. Light travels at 186,000 miles per second. That's the fastest speed possible. Nothing with mass can reach it, but let's imagine we somehow could. Even at the speed of light, crossing the universe would take an impossibly long time. To reach Proxima Centauri, the nearest star, would take 4.4 years at light speed. To cross the Milky Way would take 100,000 years. To reach Andromeda would take 2.5 million years. To cross the observable universe would take 93 billion years. Nearly 7 times the current age of the universe. And we can't reach light speed. With realistic technology, we might someday reach 10% of light speed, maybe 20%. At 10% of light speed, reaching Proxima Centauri would take 42 years. Reaching Andromeda would take 25 million years. Crossing our own galaxy would take 1 million years. These aren't engineering problems. They're not challenges we might overcome with better technology. They're fundamental limitations imposed by the nature of space-time itself. The speed of light is the speed of causality, the speed of which information can propagate through the universe. Nothing can go faster. This means the universe might be fundamentally unexplorable. Even if we develop perfect propulsion systems, even if we solve every technical challenge, even if we achieve near-light speed travel, the distances are simply too vast. We might be confined to our local neighborhood. Perhaps we could reach nearby stars within the Milky Way, establishing colonies within a few hundred or few thousand light years of Earth. But beyond that, the galaxy's far reaches other galaxies. The broader universe, all of it, might be forever beyond our physical reach. We can observe these distant places. We can study them with telescopes. We can analyze the light they emit and learn about their properties. But we might never go there. We might never touch them, walk on them, explore them directly. The universe is vast. We are small, and the speed limit of light ensures we'll likely remain isolated in our tiny corner of the cosmos. The observable and the actual. Here's something that should really make you think. Everything I've described so far, the solar system, the Milky Way, the local group, the Virgo supercluster, Laniakea, the cosmic web, the 93 billion light-year observable universe. All of it might be just a tiny fraction of what actually exists. Asterisk. The observable universe is limited by how long light has had to travel since the Big Bang. Beyond that limit, there's more space, more galaxies, more stars. We just can't see them because their light hasn't reached us yet. Asterisk. How much more? We don't know. The universe might be just slightly larger than what we can observe. Or it might be vastly larger, millions or billions of times bigger. Or it might be infinite, extending forever in all directions without end. Asterisk. If the universe is infinite, then everything I've described, all the galaxies, all the stars, all the planets, the entire observable universe is literally nothing compared to the totality. An infinite universe would contain an infinite number of galaxies, an infinite number of stars, an infinite number of planets, an infinite number of everything. Asterisk. In an infinite universe, there would be infinite copies of Earth, infinite copies of you. Every possible variation of history would exist somewhere. There would be Earths where dinosaurs never went extinct, Earths where humans never evolved, Earths exactly like ours except you made different choices. An infinite number of versions of reality, all existing simultaneously in different regions of infinite space. Asterisk. This might sound like science fiction, but it's a genuine possibility that cosmologists take seriously. If the universe is infinite and space is filled with matter, distributed roughly uniformly on large scales, which observations suggest is the case, then infinite copies of everything must exist somewhere. Simply as a matter of probability. Asterisk. We don't know if the universe is infinite. We might never know, but the possibility exists, and if it's true, then even the incomprehensibly vast observable universe is quite literally nothing compared to the total reality. Asterisk. What we've learned. Asterisk. Let's summarize this journey through scale. Asterisk. We started in a room, a space a few meters across, completely familiar and comprehensible. Asterisk. We expanded to neighborhoods, cities, country scales measured in miles or kilometers, still comprehensible, still human scale. Asterisk. We reached Earth's scale, 25,000 miles around, large, but still explorable. We mapped every part of it. We know our home planet well. Asterisk. Then we left Earth. The moon sits 240,000 miles away, 30 Earth diameters of empty space, closed by cosmic standards, but far enough that it took 3 days to reach even with powerful rockets. Asterisk. The sun sits 93 million miles away, a distance so vast that light needs 8 minutes to cross it, a distance that would take 3 generations of continuous driving to traverse at highway speeds. Asterisk. Our solar system extends billions of miles. Neptune orbits nearly 3 billion miles from the sun. The Oort cloud extends trillions of miles out, nearly to light years from the sun. Asterisk. The nearest star is over for light years away, 25 trillion miles, a distance so vast that our fastest spacecraft would need 75,000 years to cross it, a distance that would take 40 million years to drive. Asterisk. Our galaxy is 100,000 light years across, containing hundreds of billions of stars. Light takes 100,000 years to cross it. At this scale, the solar system shrinks to a point and Earth vanishes completely. Asterisk. The local group spans 10 million light years, containing about 80 galaxies. The Virgo supercluster spans 110 million light years, containing thousands of galaxies. Laniakea spans 520 million light years, containing 100,000 galaxies. The cosmic web extends billions of light years, with filaments containing millions of galaxies surrounding vast voids where almost nothing exists. Asterisk. The observable universe spans 93 billion light years and contains about 1 trillion galaxies. And even this incomprehensibly vast structure might be just a tiny fraction of the actual universe, which could be much larger or even infinite. Asterisk. At every step of this journey, we've seen the same pattern. What seemed vast at one scale becomes tiny at the next. Your city seems large until you compare it to your country. Your country seems large until you compare it to Earth. Earth seems large until you compare it to the solar system. The solar system seems large until you compare it to interstellar space. And so on, each scale dwarfing the previous one by factors of thousands or millions or billions. Asterisk. By the time we reach cosmic scales, galaxies, galaxy clusters, superclusters, Earth has ceased to exist in any meaningful sense. The difference in size is so enormous that no analogy captures it. Earth is smaller than an atom compared to the observable universe. Actually, Earth is smaller than a quark. The ratio is beyond comprehension. Living in the vast. Asterisk. So how should you think about this? What should you do with this knowledge? Asterisk first, appreciate how extraordinary it is that you exist at all. Against all odds, on this tiny planet in a vast cosmos, matter has organized itself into a form that can think, can wonder, can understand. You're made of atoms forged in the hearts of stars that exploded billions of years ago. You're literally stardust, and that stardust has become conscious, capable of contemplating the universe that created it. Asterisk second, remember perspective. When things seem overwhelming, when problems feel insurmountable, when conflicts seem enormous, remember where you are. You're on a tiny planet, essentially invisible against the cosmic scale, experiencing a brief moment of consciousness in a universe billions of years old. That doesn't make your problems unimportant, but it can help you see them in context. Asterisk third, appreciate what we have. Earth is tiny, yes, but it's also special. It's the only place we know for certain that harbors life. It's the only home we've ever had, in a universe that's mostly cold. Empty space, trillions upon trillions of miles of nothing, a small planet with blue skies, flowing water, diverse life, and conscious beings is incredibly rare and precious. Asterisk fourth, recognize our shared situation. Every human being, everyone who has ever lived on this tiny planet. We share the same home. We breathe the same air. We're all made of the same atoms, all looking up at the same stars. The things that divide us, borders, nations, ideologies, are arbitrary constructs. What we share is far more fundamental than what separates us. Asterisk, and finally, keep exploring, keep asking questions, keep trying to understand. The universe is vast and mostly unexplorable, but we can observe it, study it, learn from it. Every telescope we build, every observation we make, every theory we develop, all of it expands our understanding of where we are and what we're part of. Asterisk, we might be tiny, we might be insignificant by cosmic standards, but we're also remarkable. We're the universe's way of knowing itself. Through us, matter has become aware. The cosmos has produced beings capable of understanding the cosmos. That's worth celebrating. Asterisk, the final perspective. Asterisk, let me leave you with one last thought. Asterisk, when you go outside tonight and look up at the stars, if you can see them, if you're away from light pollution, remember what you're seeing. Those points of light are stars like our sun, most of them millions or billions of miles away. Some are hundreds or thousands of light years distant. Asterisk, the faint band of the Milky Way, if you can see it, is the combined glow of hundreds of billions of stars, so numerous they blur together into light. You're seeing across tens of thousands of light years, across vast stretches of our galaxy. Asterisk, and if you look at the right spot, if you know where to find it, you can see the Andromeda galaxy with your naked eyes. A faint smudge of light. That light has traveled for 2.5 million years to reach your eyes. You're seeing light that began its journey before modern humans existed, before our species evolved. Asterisk, every photon that enters your eye tonight has traveled vast distances to get there. Light from the sun took 8 minutes. Light from nearby stars took years. Light from distant stars took centuries or millennia. Light from other galaxies took millions or billions of years. Asterisk, you're connected to these distant objects by the light that bridges the vast emptiness between us. You're seeing across incomprehensible distances, across scales that dwarf everything in human experience. Asterisk, you're able to understand what you're seeing. You can comprehend, at least intellectually, the distances involved. You can grasp that the universe is vast, the earth is tiny, that we're part of something so enormous it challenges comprehension. Asterisk, that understanding is a gift. A product of centuries of scientific inquiry, of countless observations, of brilliant minds piecing together the nature of reality. You're living at a time when humanity understands its place in the cosmos better than ever before. We know where we are. We know how vast the universe is. We know how small we are. Asterisk, that knowledge should humble us, should awe us, should change how we see ourselves and our world. Asterisk, the universe is vast beyond imagination. Earth is tiny beyond expression. And yet, on this tiny world, in this brief moment of cosmic time, we exist. We think. We wonder. We understand. Asterisk, that's not insignificant. That's extraordinary. Asterisk, if you've made it this far. Thank you for joining me on this journey through cosmic scale. If you found this exploration valuable, a like or subscribe would really help the channel continue making content like this. These deep dives take enormous effort to research and create, and your support makes it possible. Asterisk, and remember, you're not just on Earth. You're not just in the solar system or the Milky Way. You're in the observable universe. A structure 93 billion light years across containing a trillion galaxies. You're part of something vast, ancient, beautiful, and still mostly mysterious. Asterisk, the universe is big. Really, really big. But you're part of it. And that's worth remembering. Asterisk, sleep well tonight. And when you look up at the stars, remember, you're seeing across distances so vast that the human mind cannot truly grasp them. But you can try, and in trying, in reaching toward understanding, you're doing something remarkable. Asterisk, good night. And may you never see the cosmos the same way again.